Good morning also from my side. The title in the announcement was a little bit confusing. It's not so much about OGC API, but it's about running OGC API as a smart contract. And I did a test implementation on Motoko on the internet computer. First problem, where to... I don't know. Okay, this one. Okay, in the last few years I've read some articles about Web3 and all this new technology, blockchain and whatever. And I found within those articles quite a lot of nice promises that really triggers me on. It's about ownership, giving control back to the users, not on central platforms. And this all in a decentralized and trustable way. So, yeah, I was not sure if those articles are more than buzzwords or how this fit to our GI or SDI world. So the way that I did it was, yes, trying it out, try a test case and see how this runs. And I want to go with you step by step through this test case and how this all went out. So first these building blocks, so what's blockchain, etc. Very short. My setup, my simple scenario, and then my first experiences. And as I said, first experiences, it's not done yet. So what is a blockchain? This is the key technology for Web3. And blockchains are so-called distributed ledger technologies, meaning that you have got a distributed network of nodes, and within these networks you manage those ledgers, which are nothing more or less than lists of content, and you can add to those lists, but you cannot manipulate the existing part of those lists. Maybe the front. Better this way? That's bad because I've got quite a lot of blue and green within the slides. Okay. Is this working a little bit? So I. Okay. Yeah. I try to depict it a little bit. So a blockchain network. So I've got a few running nodes within your network, but without a central node. And those nodes, they carry these blockchains. And the complex thing on that is how to synchronize those blockchains, because they are exact same copies in every node. So this is most complex thing, the consensus mechanism on these blockchains. So what can be within such a blockchain or within such a block? In fact, any digital data. So it can be data or transaction, like on Bitcoin, the most prominent blockchain, but it can also be executable code. And if this code is executable on these nodes, you talk about smart contracts. So executable code that's triggered from outside and executed with on these nodes. So that's the interesting thing on that. And if you expose interfaces to the end users via web, you talk about these distributed apps or dApps. Another buzzword, yes. So my question was how to code on those smart contracts and how to build such front ends. Yes, and so I asked myself, can I code an OGC API feature on this technology? So I set up a really simple scenario. You guess you cannot read it. So uploading some data to a web front end, storing it, and exposing the data via OGC API. This is stupidly simple, but it shall run within this blockchain. So that's the interesting part, I guess. Okay, so before coding, I have to answer some questions. First, which blockchain ecosystem to use, what data sets to use, and how does this coding in fact work. And yes, I looked at a few blockchain ecosystems. There are quite a few of those. They shall be open from my perspective, using open source, and of course be more or less documented, because I started this. Yeah, so I choose, I don't know if it was best choice, but anyhow I choose the internet computer, because you can expose and use HTTPS communication. It's got a nice storage model, identifier management, and a really nice feature, which is a prepaid model. For the data sets, I use something that I knew well, and where I've got complete ownership on it. So I use some self-made data. I choose IGC tracks. These are tracks you record when flying with a glider. So this is a standard for gliders and paragliders. And last not least, of course, what's the technology stack that I have to use or will use? And this is more or less defined by the selection of the ecosystem. So all this static content, yes, that's plain HTML, CSS, etc. And more interesting is how does backend work. And in fact, you can code within this internet computer ecosystem with two programming languages. One is Rust and the other is Motoko. And Motoko is specifically designed for this internet computer. So yeah, I choose this, learn something new. It's a quite complex, no, not so complex, but a well-suited programming language with object-oriented and functional aspects. Okay. If you decide to code, then you need to deploy your code somewhere, and you need a kind of deployment target. And on this internet computer, this deployment unit is this so-called canister. So that's the place where you deploy your code in. So we've got a payload, the content, and additionally you have got an identifier, a principal and an owner. So this is managed within this container. And finally you've got some fuel, how it's called. So this is a kind of prepaid execution time for this container. So you have to charge before executing the code. Yes. Have a look at the payload. So yeah, it's crappy, but yeah, anyhow. We've got this is the payload with the static content and also the backend content. And what's interesting about this is that every canister has exactly one actor, and the actor defines more or less the interface to the outside. So you can define queries which are really fast and cheap, and you can define transactional interfaces that are much slower, in a second time, and more expensive because you have to deploy the state over the other nodes. That's the expensive part on that. Having a look at such an actor, this is the classical hello world. Everyone who's familiar with coding would see this. So you've got a function and a parameter list and an asynchronous response, because you cannot always trust the communication within the internet. Yes. A few pictures of the application as it is now. So this is the management part, so where you upload your data and view your data. So I upload here some tracks, and you can see how I flew around and whatever. Another endpoint is the OGC API endpoint. So this is a typical grabby HTML representation, not so nice, I know, but with all these path encodings in it. And finally, using the same endpoint from QGIS, you can view your data within QGIS directly. Yes, so my experiences with this test case. So it was a kind of hobby project for myself. So first experience is it works. So I finally managed it to, I can run such software on the blockchain. It works. I've got two endpoints, one this management DApp with static content and Motoko backend, and the other the OGC API features with this query function on this HTTP GET. Yes, but it was quite painful. It was, for me at least, a quite steep learning curve to get into this ecosystem with all these blockchain slangs, what are identifiers, what are coins, and how to change coins, etc. I found it quite challenging, at least for me. It's a complex technology mix, so with a lot of interdependencies, so the front end, the back end, the configurations, the charging, the identifiers. It was really, or it is really hard to lock those applications because the focus on the distribution. So it's hard. And this Motoko language really fits well into coding these contracts, but you've got no libraries at all. So even this JSON composition, you have to do it by text blocks building together. So it was, quite painful. There's, I don't know. Another experience is, yes, that application does not make any sense at all. So I just have this technical test. So the test scenario is still a simple centralized application where you upload your data. You've got no authentication, no authorization. The owner of the service, the person who's running the service, is the boss of the application. I can switch it on, switch it off. Change data of the users or whatever. So the data owners lose their ownership, in fact. So what shall come next? Yes, to adjust the scenario, to get a little bit in touch of this, how to call it, on this ownership thinking. So the goal shall be to give the users, the data owners, the control on their data. And my idea is to use a authentication framework, something standardized, and to have one management container, and for every user create dynamically an own container or canister, and hand the complete ownership to the user. So the owner of the data can start and stop or manipulate their service on their own. So yes, another great picture of mine. So the idea is that you have got this kind of management application using identities, and for each user you shall have an own canister running with an own interface. So each user can decide on its own how to run this. Even if the management application stops, it shall still exist. Okay, so yes, I did some tests. It already worked out quite nice, but it's not, you see it, it's a little bit on the testing phase now. So this is the management console, so each user gets this personal identity principle, and then can start and stop only his own canister and not the manager anymore. Yes, more or less that's all. I've got quite a long list of links, so the landing page of this test application is listed here. Then the code repository is listed there. And finally, some more information about the Internet computer, about this programming language. And I have to thank to the Definity.org who gave me a grant so that I can at least run those services. So that's also quite a nice thing. Another nice thing is there's another GIS application running on the Internet computer already. This is the WMTS, IC Maps he called it, which a little bit a similar model, so giving the users their full ownership on their data and on their service, yes, but running a WMTS. Yes, I guess that's all from my side, and yeah, thank you very much.